Hello and welcome to SciJoy. We're going to build a robot that the internet controls. We've kind of done this already. We had a Lego robot that you guys controlled by writing comments in certain YouTube videos. You wrote forward, left, backwards, and right. And YouTube thought you guys were bots, so it eventually sent all your messages to spam. It worked for a little bit, but as soon as it thought that you guys weren't real people, it kind of shut down everything. So we're going to do it differently. One, we're going to build our own robot from scratch. We're not going to use a Lego robot. And two, we're going to use something else to control the robot. We're thinking tweets right now, but we're not really sure. But that's part of the experience. We're going to take you with us this time. A lot of times we film everything as we go, and at the end we put it all together into steps and a story and tell you what we learned. But this time you're going to come with us on the journey and see our mistakes, our mishaps, and all the pivots that we make, and hopefully some triumphs too along the way. So when we're starting out, there's a few things we need for our requirements. One, we want the internet to control the robot. Two, we want this robot to be made mostly out of parts that we already have. And three, we want it to be able to drive around. And that's what you're going to control. So we need something that's going to be able to talk to the internet for the brains of our robot. There's a couple of things we already have. We have an Arduino Uno, a Raspberry Pi 3, a Raspberry Pi Zero, and ESP32s. ESP32 and the Raspberry Pi Zero are pretty small, so I'd like that for the base of our robot, and that might be our robot brain. I think right now we're leaning towards the Raspberry Pi Zero. And the actual physical model of it, we're going to 3D print. We're going to CAD something along the way after we know all the pieces that we're going to use. We're going to use 4 different motors. They're TT type motors. We got ours from Amazon, but you can also get motors from Adafruit or SparkFun. If you're getting a lot of these other parts to build your own, you might want to go from there because they have better documentation and better support along the way. Adafruit also has metal ones, so if you want a higher torque robot, you can go there. And SparkFun has motor kits that actually have encoders with their motors. They have Hall effect ones, so you have a magnet and a Hall effect sensor, and it's going to be able to tell how fast and how far your robot's going. We already have optical encoders, so that's what we're going to use for ours. And these optical encoders don't go off the regular 3.3 volts that it's given out by the Pi Zero, so we're going to need a converter to get the proper voltage to them. And we can't just drive our motors from our Pi Zero, we're going to need a motor driver. We already have a Feather motor driver, so that's what we're going to use. I'm hoping that I can figure out how to put CircuitPython on our Pi Zero, because CircuitPython has a great library for this Feather motor driver. It's just simple codes. I think it's like throttle.m1, which is motor 1, and you pick a number from -1 to +1. So -1 is negative 100% power, and +1 is positive 100% power. And if you wanted it halfway, you pick 0.5. So it's really easy code to be able to control the 4 motors. So I'm hoping that that works out. And I want to be able to see, so there's one of 3 options for that. My first pick is an IR sensor that we already have that will tell a depth to an object. The second is ultrasonic. And the third, if we have time, maybe we'll put some kind of a camera on it so the viewers can actually see where they're going. We'll see what we have time for, and I think that's the basic overview of what we're doing. In the next video, I'm going to show you how I set up the Raspberry Pi Zero, and the following video after that hopefully is going to be us soldering the parts of the motor together and coding it and hopefully putting CircuitPython on the Raspberry Pi Zero. So I hope you join us for this journey along the way so you can learn and build with us. Thank you so much for being with us today, and I will see you next time.